All right, let's do some Mathity-Math. Today we're going to talk about how to create a scatter plot and then how to describe the correlation type and strength of your scatter plot. Here we go. It says, Willie the woodchuck asked all of his friends how much wood they chuck each week. He wrote down the mean amount of wood chucked based on the age of the wood chucks. This is based off the famous tongue twister. How much wood could a woodchuck chuck if a woodchuck could chuck wood, right? Okay, so we're going to find out. Looking at this, we want to make a scatter plot. Okie dokie. So we're just going to make an X and Y axis to make our scatter plot. And we'll talk about how to label it and number it and go from there. Okay, so here's my Y using my box of a marker for a straight edge. And here's my X. Remember, guys, this is just a sketch to help us understand the trend and strength of correlation of the data, okay? And so this is just perfect. And so when we look at this, we need to figure out which one will be our X and which one will be our Y. And again, this is all about dependency and independency. So you can ask yourself, does the age of a woodchuck depend on logs chucked? Right? Or does the logs chucked depend on the age? Well, obviously, chucking logs does not make people age faster or slower. So the logs chucked depend on the age. So that means the age is independent. So X is always independent. So we're going to go down here and we're going to make this our independent. Starting with 0, and we're going to go all the way up to 11. So it's going to be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, I'll put those numbers in because I don't want to make a mistake just because I was too lazy to write a couple numbers. It's math class after all, right? Right. Okay, and then coming up here, we're going to put the logs chucked. Logs chucked, the highest number is 30, so maybe I'll just overshoot and I'll go to 35. So I'll just do 5, 10, 15, 20, 25, 30, 35. So that's 35, 30, 25, 20, 15, 10, 5, and then 0, 0 right there. Cool. At this point, just make a quick note so you remember this is your X and this is your Y. Okay, and let's take a look at this and just plot some points and see what happens. So it says when the woodchuck is 2, they can chuck 30. Ding. When the woodchuck is 3, they chuck 24. Ding. When the woodchuck is 4, they chuck 19. Ding. When the woodchuck is 5, 15. And you can see where this data is going already. When it's 6, they throw 12. They chuck 12. When it's 7, they chuck 9. When it's 8, they chuck 6. When it's 9, they chuck 5. When it's 10, they chuck 4. And when it's 11, they chuck 2. So, there you go. This is a nice little scatter plot here to visually represent the data. And from this scatter plot that we just quickly sketched out, we can actually kind of see and get a feel for the data. It says, depend the type and strength of this correlation. Well, the type of this correlation is negative because it's shifting down as we view it. It's shifting down. When it's negative, as the X values increase, the Y values decrease. Okay, so that's a negative correlation. Okay, and what is the strength of the correlation? Well, if you look at this, you can pretty much lay down your marker and hit every single point, right? Like, watch out. They all pretty much disappeared. That tells you they're pretty tightly packed in, and that's why we call that a strong correlation. So I could say this is a strong negative correlation. And if those points weren't so tight, they just kind of spread out, and you could still see it's negative, you could say it was a weak negative. But because they're so tightly packed on that line, we call that a strong negative correlation. All right, that's it. Good job. I'm sure you did great work. Please remember, if you want to be notified when I make more problems for you, That sounds pretty bad. Anyway, subscribe, and if you need to talk about something or there's something you want to see, just go ahead and comment below. I'll do my best to take care of it. Thank you. Bye.